All right, C3 and C4. Both of these don't have parentheses. So what we need to remember to do is we need to get them from expanded form to factored form first. Then we can do the same work that we just did in C1 and C2. So here we go. So I have here 0 is equal to 2x to the second plus 32x. All right, so I need to look, what specifically can I factor out of both of these? Well, 2 and 32, I can get a 2 out of both of those because that's the greatest common factor between them. So I definitely know I'm gonna have a 2 coming out. And then notice how both of these would have x's. This is x to the second, this is an x. So I'd factor out an x as well. So when I do that factoring, remember when we would do that, you have a 2x to the second divided by 2x. So in this case, if I do 2 over 2 is going to be a 1, x to the second divided by x. Remember that whole thing we did a while back about subtracting those? I'd be left with the plain old x on the inside. Then over here, this other one, I would have a 32x divided by 2x. 32 divided by 2 is going to give me a 16. X over x is going to be that. So that's going to be what we work with, is this set up here. So this is the new thing set up to equal 0. So I know I'm going to have 0 is equal to 2x, and I'm going to also have 0 is equal to x plus 16. So when I do that, this one's pretty straightforward. Divided by 2, x will equal 0. And over here, I'm going to do minus 16 and minus 16. X is going to be equal to negative 16. So those are my answers. X equals 0 or x equals 16. But let's check those just to be sure. So I'll set this come over here. We'll do first of all where x equals 0. Make it y equal to 2 times 0, all that times 0 plus 16. Well, 2 times 0 is 0. 0 plus 16 is going to be 16. So 0 times 16, x equals 0. That checks. Same thing for this other part here. I'll put in x equals negative 16 this time. Y equals 2 times negative 16. All that going to be multiplied times negative 16 plus 16. Well, 2 times negative 16 is going to be a negative 32. Negative 16 plus 16 is going to be 0. So I multiply that together, I'd get y equals 0. And that checks as well. All right. Last one in part C. (18x minus 9x to the second equals 0. So here we go. 0 equals 18x minus 9x to the second. Okay. So remember, this is an expanded form, so I need to factor something out. Well, what do these guys have in common? Well, I see that this is 18 and 9. I'm going to be able to factor out a 9 for sure in these cases because that goes into both. And then these both have x's as well. So I'm going to have a 9x coming out. So when I do that, I would have 18x divided by 9x. This is going to leave me with a 2. Put my minus sign. 9x to the second divided by 9x is going to give me a plain old x. And that's how we would end up getting that factored there. And then I would set all that equal to 0. And with that, I begin to spread that out. 0 equals 9x, and 0 equals 2 minus x. Divide by 9, divide by 9. X we know is equal to 0. And in this case, I'm going to move my x over to keep it positive there. X equals 2. So those are my answers, just like that. So let's test that. So I'll come back up here and plug those in. But I'll use x equals 0 first. So y equals 18 times 0 minus 9 times 0 to the second power. Well, this is going to be 0 minus 0 to the second power times 0 is going to be 0. So yeah, y equals 0. So that checks. The other one we have is putting in 2. So in this case, I will do x equals 2. Y equals 18 times 2 minus 9 times 2 to the second power. All right, so 18 times 2, that's going to be 36, minus, remember here, if I'm going to have 9 times 2 to the second power, that means 2 to the second power is going to be 4. So 9 times 4 is going to be 36 as well. So there it is, y equals 0. And that checks as well. All right, guys. Hopefully this is making sense. It really, really feels kind of abstract and strange and what the heck and why are we even doing this? Because it is a way to work with quadratic functions. It's a big, big part of working in math. For those of you that are going to be prepping for Math 2, there's going to want you to know about this going into your high school years. Those of you going to be going to Math 1, you'll see this again, but it's good to have a head start on some of that information. So we move to question D on this part. We're actually using a real scenario, an actual real bit of information. And so I want to make sure I explain some of the details of how it's going to play out first. So let's take a look at it. All right, question D. They're asking us to use this information here to look at this idea. So you can approximate the height h of a pole vaulter from the ground after t seconds with the equation h equals 32t minus 16t to the second power. Okay, before we even start, let's talk about a pole vaulter. Some of you may or may not be aware of it, and if you are, that's great. If you're not, why don't you stop the tape and go Google like pole vaulting videos to understand a bit. But basically what it is, bear with me and my fantastically wonderful art skills, is it's a track and field event. And so you have a person over here that holds this big giant pole. That's really not good. And they have this big long stretch to run, and there's these two poles up here, and they hold a bar across the middle. There's a big landing pad here. What this guy does is he runs all the way down this track to build up a lot of speed, and he puts this pole in the ground. So the guy's running, and he uses this pole, he puts it in the ground like this, and he uses that to propel himself up over the bar and back down to the mat. Now, that's what pole vaulters do. But the idea we have to understand here is the motion of what the pole vaulter goes through is in fact creating that parabola shape. It is actually going to be a quadratic function. And so what we need to do is use this information to figure this out. And so what they're telling us that the model of this situation is going to be h is equal to 32t minus 16t to the second. And what they're saying here is the height is going to be h, and the t is going to be time in seconds from the pole vaulter from the ground after that time. So basically, we look for those zeros. So you imagine that's going to cross here and cross here. So we're looking for this information where it's going to hit these 2 points. Even though it kind of stops here, we want to think about that process. Even though this mat's up high, it's where that would work through. So what we need to do is we actually need to go through and do our work to solve this to make sure we understand what we're doing. So here we go, look at this. Number 1, suppose the pole vaulter writes the equation 0 equals 32t minus 16t to the second. What information is the pole vaulter looking for? First of all, let's do that to see what's going on. So if I create this set up here to be 0 equals 32t minus 16t to the second. Well, I need to factor these things. What do these guys have in common that I could factor out? Well, yeah, 32 and 16, those are going to be, greatest common factor is going to be 16 because it would go into both. So I'm going to have a 16 come out, but also they both have t at the same part. So I would need to factor out a t as well. So if I have 32t divided by 16t, that's going to leave me with 2. Then I'm going to be subtracting that. Then I'm going to have a 16t to the second minus 16t. And that would leave me with a plain old t in that case. So now I have a new factored form of this, 16t times 2 minus t. All right, so let's go in and figure out where the zeros are in this case. So 0 equals 16t and 0 equals 2 minus t. All right, so what this happens here is I would divide by 16 and divide by 16. This is going to be gone. I got plain old t. 0 equals, or 0 divided by 16, it's going to be 0. In this case, remember we're going to have our t be positive, so I'll do a plus t here and a plus t here. T would equal 2. So those are the answers. Now, t is going to be seconds, okay? T is seconds. So in this case, if you remember, at 0 seconds and at 2 seconds, this is what we're looking at. So you can see if I plug these in, does that make sense that at 0 seconds, running this way, it'd be at 0, and you can see that's where it would start. Then after 2 seconds, they would be back down at that 0 thing again. So when they're saying, what do you think the pole vaulter is looking for? In this case, the pole vaulter is looking for the amount of time it will take for him or her to land. And that kind of makes sense. If you think about time going by, someone's running, put that thing in here, 2001, 2002, they'd be back down. So that's what they're looking for. They're basically looking for the T is going to be the amount of time it takes, time for this pole vault to take place. All right. Now, here's where things are going to change quite a bit for us. The pole vaulter wants to clear a height of 17.5 feet. Will the pole vaulter clear the desired height? We need to explain that. Well, where is that height going to be? If you look carefully at our little parabola here, if this is 0 and this is 2, what would be right in the middle of those? Going right up here in this case here, that would be where the height is. That would have to be happening right in the middle of those two places. It would be the highest you get to would be in the middle of those two cases. So this is going to be at 1. So if I plug 1 second in here for my time, that will tell me how high they will get. So let's do that. So in this case here, we're now going to do for h, because we want h to be that setup. We're going to put our time is equal to 1. So height is equal to 32 times 1 minus 16 times 1 to the second power. Okay? So it turns out that we need to go through and do that work. Oh, hi, my dog is saying hello to everybody. 32 times 1 is going to be 32 minus 1 squared would be 1 times 16 is going to be 16. So in this case, if I have 32 minus 16, it turns out that the height would be 16. So our question takes us to, the pole vaulter wants to clear a height of 17.5 feet. Will the pole vaulter clear that desired height? Well, it turns out from our work here, the height is going to be 16 feet, because height is represented in feet. So if our answer is 16, will they be able to get to that part? No, they're not high enough. Not high enough to clear 17.5 feet. All right, guys, hope that makes sense. Let's do a quick check on the ACE work. For this assignment, you're going to be doing 27 through 34. All right, 27 and 29. First of all, solve each equation for x. Check your solutions by using a calculator to make tables or graphs. So that's a good way to help you out there. Be careful because there's decimals here, but basically each of these are already in expanded form. You need to take it back to factored form, just like what we did in our practice work today. Number 30, kind of a funny one. We have, instead of a pole vaulter, you have a flea doing a jump after these seconds. So first things, well, this is the equation. Height is equal to negative 16t squared plus 8t, sorry. Then we have, is the equation linear, quadratic, or exponential? Well, we should know that one already. Write any expression that's going to go with that to make sure this would be equivalent for this setup here. Negative 16t to the second plus 8t. Then without using a graph or table, find the time when the flea lands on the ground. Remember, it's going to be that jump, that same process, just like the pole vaulter. Okay, number 31. Specifically, use an area model. So I want you to go back and do that. Now, this is tricky with the area model, but think about how you'd factor that part out to get those guys back into factored form. 32, you have use your answers for 31 to solve each equation. Notice how these are all the same. So you're going to go back and actually solve these by putting them into factored form. So you're basically 31 and 32 are doing the exact same work, just going a little step further. And then for 33 and 34, they want you to go through and look at both of these situations and see where the mistakes were. So it says find the error and correct it. And how would you help a student who made this error? What would you write or what would you do to help them understand? All right, so this was a long one. Hopefully you guys are making some sense of it. Again, hopefully after reviewing of problem 3.3, it's making some sense. I know it's going to be tricky because this is new, we're not together, but hang in there. I'm going to be available for other times for answers as well. Send me your questions, connect with me, Remind app, or email me and we can work through it. All right, see you guys next time. Bye-bye.